Assalamualaikum warahmatullahi wabarakatuh to Madam, and this is my video of the progress my final project, which is series and parallel in RL circuit. Objective to measure phase difference between voltage and current in an inductance, understand the inductive reactance and verify theoretically, determine the effect of frequency on inductive reactance, determine the voltage and current in series and parallel RL circuit. This is my introduction about RL circuit, which is a resistor inductor circuit or RL filter or RL network. Is an electric circuit composed of resistors and inductors driven by voltage or current source. An inductor, also called a coil, choke, or reactor, is a passive two-terminal electrical component that stores energy in a magnetic field when electric currents flow through it. The inductive reactance is calculated using the following formula, which is XL equals to 2 pi times frequency times inductor. Meanwhile, for calculations of total impedance of the circuit is given by Z is equal to square root R square plus XL square. This is in this figure 2 is the circuit is in series. Meanwhile, in figure 3, the circuit is in parallel. This is the results after the simulations have been made, which for the frequency 10 kilohertz, the inductive reactance was 3.1416 kilo ohm, and the total impedance was 3.3630 kilo ohm. Meanwhile, for 100 kHz, the inductive reactance was 31.4159 kilo ohm. Meanwhile, the total impedance was 31.4388 kilo ohm. This is the calculations that I have made for the frequency of 10 kHz. The theoretical value for each inductive reactance and total impedance at frequency 10 kHz and frequency 100 kHz. In this table 2 is where I record the values that I have obtained from the simulation, which simulation of voltage and current in series RL circuit at 10 kHz by using multisim. 10 kHz for the voltage at the resistor 0.503 volt. Meanwhile, the current 0.42 milliampere. Meanwhile, at 10 kHz, the voltage for inductor is 1.322 volt. Meanwhile, current 0.2 milliampere. For 100 kHz, the voltage at resistor is 0.054 volt. Meanwhile, the current was 0.044 milliampere. At the inductor, the voltage was 1.413 volt. Meanwhile, the current was 0.044 milliampere. This is the picture of the simulation occur by using multisim. Meanwhile, this is simulations occurred using oscilloscope by using Porteus 8 demonstration. This is the sine wave that I have obtained from the oscilloscope. This is the simulation of voltage and current in series RL circuit at 100 kHz by using multisim. And this is the simulation occur by using Proteus 8 demonstration with using oscilloscope. For table 3, for the frequency 10 kHz, the total impedance was 1.1210 kilo ohm. For 100 kHz, the total impedance was 1.1991 kilo ohm. The calculations are being made at the middle of the table. In this table 4, I have recorded the simulation that occur in parallel RL circuit at 10 kHz and 100 kHz by using multisim. For 10 kHz, the voltage is 1.4144, meanwhile the current 1.178 mA at the resistor. Meanwhile, at 100 kHz, the voltage was 1.14 volt and current 1.17 mA at the resistor. At the inductor, for 10 kHz frequency, the voltage was 1.414 volt and current 0.449 mA. For 100 kHz frequency, at the inductor, the voltage was same 1.414 volt, meanwhile the current 0.0448 mA. This is the picture of the simulation occur by using multisim for both 10 kHz and 100 kHz frequencies. Discussion. Based on the theoretical, the value inductive reactance XL of series RL circuits for both frequency 10 kHz and 100 kHz was determined by using formula XL equal to 2 pi times frequency times L. The values that I have obtained from the table above, I wrote it down at the discussion part and compare it with the theoretical. Most of the values that I have obtained from the measured in the simulation was almost same with the theoretical value. This is the calculation that I have made for series and parallel RL circuit at 10 kHz and 100 kHz frequency. For current IR, for the theoretical value, I use Vmax divided by Z, which is total impedance. Meanwhile, for voltage, I use the formula that I use Ohm's law formula to calculate the voltage values. For series, the current was same, which is IL is equal to IR, which is the total was 0.4205 mA. Meanwhile, this is the calculation of phase angle at frequency 10 kHz and frequency 100 kHz. Calculation for current and voltage in parallel RL circuit at 10 kHz and 100 kHz. The formula was same as above, which is XL is equal to 2 pi times frequency times inductor. In parallel, the current was calculated differently, meanwhile the voltage are same to each component, which is 1.414 volt. For current at the resistor in parallel circuit, is equal to V divided by R. Meanwhile, current at the inductor was equal to V divided by XL. This is the calculation of phase angle for the parallel circuit for 10 kHz frequencies and 100 kHz frequencies. As a conclusion, through this lab, I was able to measure the phase difference between voltage and current in an inductance with the help of friends. I was also able to understand the inductive reactance and verify theoretically by using the formula XL is equal to 2 pi times frequency by inductor for both series and parallel circuit of RL. Next, I was to successfully determine the effect of frequency on inductive reactance. In series circuit, the inductive reactance is proportional to the frequency. It is proven when the inductive reactance of the circuit increases when the frequency applied increases too. Meanwhile, for parallel circuit, the inductive reactance is inversely proportional to the frequency. It can be seen when the circuit becomes inductive at lower frequency. Other than that, I was able to manage to determine the voltage and current in the series and parallel circuit by using AC ammeter for current and AC voltmeter for voltage. Then I was able to calculate the voltage and current by using the Ohm's law. Thank you. That's the end of my final project of series and parallel RL circuit. Thank you.